So today we are going to discuss the chapter called the simple Rankine cycle. So where it is present in Thermal Engineering 1, Unit 1 and Thermodynamics of Unit 3, right? So it's one of the important units which will be useful for our to study power plant engineering subjects. So related with the Rankine cycle, in a Rankine cycle we have four essential components. One is boiler, turbine, condenser and pump. So boiler is another name of the boiler is steam generator. So where the heat is added, because boiler generates the steam by heat addition, right? The heat addition from the furnace. From the furnace the heat is added to the boiler. So in a boiler the water is evaporated and becomes a steam, and the high pressure steam is sent into the turbine. So where the turbine is a mechanical energy producing device or a mechanical work producing device, right? So therefore the high pressure steam enters into the turbine and tends to rotate the turbine, thus producing the electricity, right? So what's happening inside the turbine is the expansion process happening. The high pressure steam from the boiler enters to the turbine where it expands. So therefore the pressure gets reduced. So after that the exhaust from the turbine is sent to the condenser where all the heat are rejected by water cooling. By supplying the cooling water here, cold water. So it's like a heat exchanger, right? So after rejecting all the heat, the phase changing happens. That means the hot vapor is converted to the liquid water. So after that, by using this pump, it is pumped into the boiler. The process is cyclic. So this is the basic concept of a single Rankine cycle. So we are going to read the parameter of all those things. A boiler is a heat added device, right? Therefore the Q is positive. And where the turbine is a work giving device, it produces mechanical work. Therefore the W is always a positive. The condenser, so as we know, condenser is a heat rejecting device. It removes all the heat from the hot vapor. So therefore, there the Q is negative. That means the heat rejection taking place. Pump, where the compression process is taking place. So when you look at the basic concept, when you are adding heat to some element or gas, the entropy increases. So when you are reducing the heat or when heat is rejected, the entropy decreases. So when compression and expansion, the S is equal to constant. So this is the basic terms we have to read. That is when the heat is added, the entropy of the system get increased, and when we are rejecting the heat, the entropy remains down. And at compression and at expansion, adiabatic expansion and adiabatic compression, so S is equal to constant. So by using this I am going to put the TS diagram for this. So it's a very simplest way I am going to say about this simple Rankine cycle through this graphical representation. So we are considering temperature in a Y column and entropy in this column, right? So always remember when we are studying about the Rankine cycle, we have to remember the saturation line in the Molière chart, right? So here I am drawing the saturation line. So this is said to be a saturation line. So beyond this line, the vapor is wet condition, and above this line, the vapor is a superheated condition. So let's start with the diagram. The saturation line. When we split the saturation line, so the left hand side near this T column is saturated liquid line. This is said to be a saturated liquid line, and the side afterwards is after the line is saturated vapor. So listen. So this is actually a reference line, the imaginary line. So before this line, the entire parameters are for saturated liquid, and after this line, the entire parameters for vapor line. That means, so when we are putting this line, so here take 1, 2. For example, I am saying, so from 1 to this region, it is a liquid, that is a water. and after this line it becomes a vapor. So this is actually a concept. So now I am going to draw the simple Rankine cycle TS diagram for this. Okay, listen carefully. First, when we are considering this diagram, I am putting this numbers 1 to 2. 1 to 2 is our turbine. First look at this diagram. 1 to 2 is a turbine. Already told you, turbine is an expansion device where the mechanical energy has produced. Always remember, when expansion or compression, both or happens in the isentropic, that is a reversible adiabatic process. We are assuming. Okay. So now 1 to 2 is a turbine. Turbine is an expansion device. So I'm just starting the point from here. So while studying Rankine cycle, we have three different qualities of steam. So one is a wet steam, another one is a dry steam, and another one is a superheated steam. So the quality of the steam always represents by X, that is a dryness fraction. Dryness fraction. So when X value less than 1, when X value is less than 1, it is said to be a wet steam. Right? When X is equal to 1, it is said to be a dry steam. When the X value is greater than 1, it is said to be a superheated steam. So at each and every point of steam, we have to check whether the quality of steam is wet, dry or superheated. So when we are considering this, we have three possibilities. So this is actually a saturation line. The point on the saturation line is said to be a dry steam. Always remember, you will keep any point here or here, whatever it may be. But the point on the line is always represents the dry condition of the steam. So remember, the point on the line, on the saturation line, always represents the dry steam. And the point inside this line is said to be a wet condition. And the point beyond, as I already told you, so the point above the saturation line is always said to be superheated. Do you understand this? So now we don't know the quality of steam here. If I am considering the condition of the steam is dry, I have to start my diagram from here. Right? Now I am considering the dry steam. The initial condition is a dry steam. So therefore I am starting the diagram from here. This is point 1. The turbine is an expansion. 1 to 2 is a turbine. It's an expansion. That is when the expansion, the pressure reduces. So therefore the temperature also reduces along with it. As we know, expansion and compression process will happen in isentropic mode. So therefore the entropy remains constant. That we have stated here. Right? The entropy is constant when compression or expansion happens. Here the process 1 to 2, the turbine is an expansion device. So therefore the entropy is constant throughout and the temperature reduces. So as we know, here S1 is equal to S2. We have proven. Right. Next, from the process 2 to 3 is a condenser. So condenser is a device where the heat has been rejected. The heat has been rejected in the sense the hot steam from the turbine enters to the condenser where it is cooled. So therefore the heat is rejected. When the heat is rejected, look at the entropy. When we are rejecting the heat, the entropy decreases. So therefore entropy decreases in the sense it should become like this. Right? It will become like this. And also at that time when the phase changing happens, the temperature remains constant. Always remember, when the phase changing process taking place, the temperature remains constant. Okay. Now this is condenser. Afterwards, compression. That is a pump. So pump compresses the liquid from the condenser and send it to the boiler again. This makes it cyclic, right? So therefore, pump compression. When compression, look at this. When compression, the entropy remains constant. At the same time, when we are compressing any element, what about the temperature? The pressure increases. When we are compressing, the pressure increases as well as the temperature also slightly increases. Therefore, the line comes like this. Okay, this is the next point. That is 2 to 3 and 3 to 4. Next again, the boiler. boiler. So again the boiler. Boiler is a heat addition process. We are adding heat to the boiler. So always remember this. This is actually said to be. This is said to be sensible cooling. Sensible cooling. This area is said to be sensible cooling. It is in the phase change diagram, right? So this always represents this curve, the slanting curve, the inclined curve always represents the sensible heating, and the straight line along with this graph is always remember that is a phase changing process. So once again I am telling, the inclined line always remembers you that is where should be a sensible heating going on, and the straight line always represents there is a phase changing process happening. Phase changing is nothing but the liquid is converted to vapor or the solid ice is converted to liquid. So whatever it may be, reverse or and forward. So listen carefully. So here I am adding heat to the boiler from the furnace, right? Therefore it is a sensible heating line. So slanting, sensible heating line, right? Sensible heating in the sense without changing its phase, the water gets heated. That's an important one. So up to 100 degree, water will be a water. So it is in the form of liquid. Beyond 100 degree, after 100 degree, it completely becomes vapor. So therefore, so look at this. This much is the sensible heating. Afterwards, the water starts evaporating, right? So therefore, phase changing starts. Therefore, heating is right along it. So this is process 4 to 1 is a boiler, right? This is actually a normal simple Rankine cycle.